Hello, my name is Jeremiah Wilson, and this is API Authentication Security Unmasked, a thrilling dive into authentication exploits and unbreakable defenses. We're going to jump right into it for the sake of time. So, here's the agenda, and at the end of the presentation, I will be doing a demo showing me hacking into an account using JWT misconfigurations. So, as we all know, APIs have become an indispensable part of our digital world. Now, being that it's become an indispensable part, the demand for APIs has skyrocketed. And with that skyrocketed demand, there's bound to be mistakes. You have people rushing, and so that usually ends up in flawed outcomes and hasty project completion. And something that my manager always told me is that your internal API is always one click away from becoming production. So it's better to be safe than sorry. And now here's the OWASP API Top 10 Vulnerabilities. The OWASP API Top 10 is a critical awareness document for web application security that outlines the 10 most significant security risks to APIs. And it serves as a roadmap for organizations to prioritize their defense strategies. And it's comprised of a collective consensus of security experts around the world. And it helps developers, organizations, and security teams alike to build more secure APIs. Now, what we're going to be focused on in this presentation is broken user authentication. Now, the OWASP Top 10 is on the verge. The 2023 version is on the verge of being released, and they're looking for security researchers to contribute to the finalization of this list. And that's on GitHub, where they're taking a poll and trying to comprise this list to officially put it out. Now let's jump right into it. API authentication. I'm sure we all know what API authentication is, and here's some different types of authentication. I can't go in deep into all of them due to the sake of time, but we have basic authentication, which is basically username, password, very simple. Bearer authentication, mutual TLS, and that's usually used in zero trust architecture. Then we have API keys, OAuth. OAuth 1.0 is deprecated. Now 2.0 is newer and it's more secure, and it involves access tokens, refresh tokens, then OpenID Connect with JWTs. Now JWT can also be a part of OAuth, the OAuth security flow, because JWTs are access tokens, but not all access tokens are JWTs. And here's three of the more popular authentication methods. You have OAuth 2.0, which is very widely used for its ability to scale and handle a significant number of users. It's difficult to implement, but when implemented correctly, it is very secure. Then we have API tokens and JWTs. Now, they're similar. As I said, JWTs are pretty much API tokens, but not all API tokens are JWTs, but they function practically the same. The access control is embedded within the token, so that allows simple setup and implementation, and whatever permissions that you would like to give a user would be embedded directly into the token. And they're both stateless in nature, meaning you would have to send the request you will have to send a token with every authenticated request, because the server doesn't remember anything based on previous requests. And now a problem with these tokens is, since it carries all of the authentication, if it's stolen, then the thief, the bad actor, has now gained unauthorized access. So we're going to go a little more into those three types of authentication. You have OAuth 2.0, which is typically when an end user, they would like to use a third-party application feature, which requires access to resources on another server. So then the user then gets redirected to that external site to grant the third-party application permission. Then once permission is granted, the third-party site will get an access code from the separate server to then send their request for the resources of the information of the end user. Then you have API tokens. You will create an account. And when you create an account, you're usually given a client ID and client secret. Now, the ID is public, but the secret is private. So it has to be maintained and kept secure. Then you would use those credentials, the client ID and client secret, to request your token. Then when you get your token, you now send your token with every authenticated request, because again, that architecture is stateless in nature. Then JWTs are very similar as well. You would log in, username and password, simple enough. Then when the server validates, you then are issued a JWT based on the information that you sent. JWTs are base 64 encoded, and they bundle all of the user information with a signed secret key for integrity purposes. The secret key is held by the server, and with every time you send the JWT to the server, it validates using that secret key to make sure the JWT wasn't tampered with. Now, with all subsequent requests, the JWT will be accompanied in order to verify your authorization and authentication. Now we're going to move on to some common authentication vulnerabilities. So we have weak credentials, insufficient authentication checks, exposure of sensitive information, unprotected storage of authentication credentials, and lack of rate limiting and insecure implementation of OAuth or JWT. Now, I have run into all of these in the wild, and you'd be surprised how much people decide to leave an API token or a JWT token inside of their developer notes, and they don't take it out before they send it out into production. But what we're going to be focusing on here is insecure implementation of OAuth or JWT. And now we're going to go over the components of a JWT token. Now, this is from a website called JWT.io, which we would use to edit the JWT tokens. And in doing that, we can try to break the server and allow it to give us access that we are not allowed to get. So it's comprised of three parts. You have the header, which contains the algorithm that the JWT contains. Then the payload, which typically contains some user information. It contains some personal information for the user that the JWT was created for. Then you have the signature, which contains the secret. And as I said, the server holds the secret to make sure the JWT isn't tampered with, just to verify authenticity and integrity. So now let's move on. Then we have some JWT misconfigurations. The algorithm is not validated, or the algorithm is set to none. So now when these things happen, the server will then validate the JWT, not checking to see if the algorithm was tampered with or not. It just checks if the JWT is sent. So you can send almost anything within that authorization header. A secret key weak and easy to break. So like I said, the server validates the secret. And there's ways that you can try to find out the secret. And if you are able to find it out due to the secret being weak or being something that's easily guessable, then you have a big problem on your hands, because then someone can self-sign the JWT. And if they can do that, then they have now gained unauthorized access to whatever resources they were trying to be kept out of. Do you have insecure storage, which, like I said earlier, some people like to put the access tokens in the developer notes or in a public file on the server, or just something that's not secure at all. Then we have insufficient validation, which is similar to the algorithm not being set, just checking that the JWT token is there rather than checking the contents of the token and making sure whoever is sending this request also has the authorization to get what they are trying to get. Now we're going to move on to our demo, breaking API authentication.
Hey, Jeremiah here, and I'm going to show you guys what a misconfigured JWT token looks like, as well as what a hacker or a bad actor can do to exploit that misconfigured JWT token. And first, I want to start off by saying thank you to Corey Ball. I got this concept from him, and I hope this will be very, very informative for you guys. So I'm gonna jump right into it for the sake of time. As you can see, I'm on Crappy, which is a intensely vulnerable API. And I'm gonna start by creating 2 accounts, one account to use for testing purposes and another account to see if I can break into using the misconfigured JWT token. So what I'm gonna do is I'm gonna create the accounts on Postman because it's easier to do it that way, it's faster. And I'm going to create these accounts. Apidays 5. I was messing with this earlier. Here we go. And I'm gonna do an Apidays 6. I have to change the phone number. Okay, so I have those 2 accounts created, and I'm going to show you by logging into them right now. And what I'm trying to do is when you authenticate with Crappy, what it does is it sends you a JWT token that you're going to use for your account. And I am going to intercept that token with Burp Suite and see what I can do with it. So I'm going to send this to repeater. Now here's the token. Here's the JWT token. So I'm going to take this and I'm going to put it in my notes. And then we can analyze it by going to JWT.io. So I'm going to take that token now. As you can see, the algorithm is HS512, and we have some personal information here, like my email. And then we have the signature. The signature is being held by the server just to validate the token, make sure it hasn't been tampered with, and for integrity purposes. So as we can see here, it has all this information. So we can modify this information straight from here. So now I'm going to see if the server is misconfigured in a way where I can just change this and it will accept this token. Let's try that first. So what I'm going to do is use Postman for the majority of this. Me logging in on Postman is the equivalent of me logging in here and going on this page. It is case sensitive. So this page right here is the equivalent to the user dashboard right here. So what I'm gonna do is I am going to take that token that I just changed and see if I can use that token to get into Apidays 6. Let's see. And invalid token. That is good. That's to be expected. It is not that simple to overcome the JWT token check. So next, what we're going to try is to see if the server is validating the algorithm. So there's a tool that I can use that will spit me out another token with the algorithm set to none. And it's called JWT tool. So I'm going to try that right now. And for the sake of time, I'm not going to go into the help menu. I'm going to just do that exploit right now. So let me copy this token. But the way to do the exploit is a -X. So I put in a token -X, and then A is what takes away the algorithm. So, okay. I forgot to do the .py. JWT tool.py. Here we go. So now it just gave me a new token. Let's validate that the algorithm is set to none. Here we go, algorithm set to none, still my information, Apidays 5. All right, so let's try it and see if we can access the API Days 5 dashboard with this token. Okay, so still invalid. So it's checking to make sure at least the signature is correct. And that is good as well. So the next thing that I'm gonna try is to figure out what this signature is. So since the signature is being held by the server, it is very important that your secret is something that is complex and not easy to guess. But we're gonna see if this secret is configured that way. And what we can do is use JWT tool. It has it has an option called crack, it's -C. And first what we have to do is create a word list. So I am going to create a word list and use crunch to do that. And I'm going to use 5 characters for my word list, and I'm going to name it API Days crack .txt. And now, as we see, it is generating almost 12 million lines. And now it is done. We have, where is it? API Days crack.txt. And I'm going to use this word list to see if I can crack this secret. And if I can do that, I should be able to self-sign the token, and the server should validate it. So let's do it. Take a token and then do a -C -D to set the path for the word list. And let's see, it's going to go through all 12 million of the lines to see if it contains the secret. Tested 1 million so far, and we got it. That was fairly quick. It looks like crappy is the secret. And since that was such an easy secret, we was able to crack it super fast. And that's why it's important to have a complex secret, because if I had a computer with a superpower computer with a whole lot of GPU, a whole lot of resources, then I'd be able to make like multi-million word lists, just more than you can imagine, and run through them in minutes. And that is the power of computers. So we found out that crappy is the correct secret. So what we should be able to do is self-sign this JWT token. So now that we self-signed it, we're gonna try to, you know what, I have to copy the original token again. So now we self-signed it with crappy, and we're gonna try to log in to the API Days 6 account. Now it's base 64 encoded, so I just have to copy this and bring it down to the dashboard and see if it works, see if I get access. And it looks like I got in. So this is why it's very important to have a complex secret. We went through different ways that an attacker can attack your JWT tokens, and just to make sure this was wasn't a fluke, I'm going to create another account right now and see if I could log into that one using the JWT, since I self-signed my token. 7. Copy. And let's try that. See if I could get into that dashboard. And it looks like it worked. So yeah, this is the end of my demo. I hope it was very informative for you guys, and it is very important to secure your JWT tokens. It's very important to secure your authentication, and I will talk to you.
So as you can see, it can be fairly easy to break into user account and gain unauthorized access if your JWT is not properly secured. So here's some tips for secure API authentication. Use proven and secure authentication methods. Now, JWT, OAuth 2.0, and API tokens are among the best and most popular when implemented correctly. But use the best authentication method for your API. There's more methods than the ones that I mentioned here, but I couldn't get to all of them. And implement rate limiting. If you do that, then it can prevent brute force attacks. Rate limiting is when you set a limit to how many requests can be sent at a time. You could send like 5 requests and then the account will lock out. Then you also should securely store your credentials. Don't put anything in plain text, and make sure the keys and tokens have a high entropy, which means a high randomness, and it cannot be guessed. And don't type any credentials or keys in the source code. Now, that is the end of my presentation. Thank you for listening. Thank you for your time. And you can connect with me. Here's my email and my LinkedIn. And I hope you have a great day.